Okay, so we are going to talk today about the Earth, Sun, and Moon and the characteristics involved with those three celestial bodies. Um, we have the Sun, we have the Moon, we have the Earth. Our goal today, we will identify and compare the physical characteristics of the Sun, Earth, and Moon. So we're going to do an activity today. You're going to get to watch me, I guess. Do an activity where we explore kind of the differences. And so what I've done is I've made two models, and those two models are going to allow us to experience the differences between the Earth and the Moon. Now, the Sun, we could talk a little bit about what the differences are there. Hopefully you know that the Sun is made of gas, the Earth is made of rock, as well as the Moon. I feel like the Sun's a lot easier to tell what's different about the Sun than the Earth and the Moon. So today we're going to focus more on just the Earth and the Moon with a little activity. I'm going to build two models, and we're going to collect some data on that, and then at the end try to explain what model represents the Earth and what model represents the Moon. Okay? So in your notebook, I need you to go ahead and make this chart that you see right there on your screen. We have the titles, the Sun, Earth, Moon, and then you're going to write model and leave a blank, okay? And then on the first column, I have meteor, and we go all the way to 7. Second column says hit or miss. Third column says land or water. And the fourth column says crater. I'm going to suggest that you pause the video right here to copy this in your notebook. You are going to need to copy this table twice. Okay, so that's important because I have two models and we're going to be collecting data on both of those models. So make sure you copy this twice. How many times are we going to copy it? Twice. Okay. So like I said, pause the video here. Copy it down. When you're ready to move on, we can hit play and we will move on. All right, so now that you have that table copied in your notebook, we're going to go over kind of a couple things that have to do with my model, and I'm going to take you down to the lab so you can see the model, okay? All right, what we have here is we have a model that you probably noticed right away the grid of masking tape that I put on here. Okay, so that the grid of masking tape will represent something. We're going to be talking about that in a moment. And then if you notice down in there, you can see that there's some blue liquid in the side. That blue liquid that you see inside the container, that would represent water, obviously. And then inside there's a pan and it's got white flour. So the white flour is going to represent land, okay? The tape will talk about what it represents. I'm sure you'll be able to figure it out. So what I have here is I have a bunch of different sized balls and marbles. I got golf balls and some different sized marbles. So I'm going to use those to represent meteors and asteroids. So as I drop them in your chart, you are going to tell me whether it hit, made impact with the land or water. And a hit is going to be that it actually makes it through the tape. So if it just bounces on the tape, that would not be a hit, okay? So I'm going to start off with, I'm just going to go from biggest to smallest. So I'm going to start off with this one. This is going to be an asteroid, and so I'm going to drop the asteroid. We'll see if it makes a hit. Now, it just landed on top of the tape. It did not make it through the tape, so this would not be a hit. This would be no, okay, for hit. Okay, so make sure you're filling in your chart. I'm going to drop another golf ball. So this is drop number 2, and I drop it, and it is a no. So no impact for our second one. So on where it says land and water, you just can leave that one blank, because if it didn't make a hit, then there's no way that it hit on land or water. And it also would be a no for crater. It did not make a crater. Okay, So the next one I have is this little blue marble, or I guess it's a large marble. And no impact for this one. So number 3 is no impact and no crater. I've got another large marble. I'm going to drop it a little higher. Let's see if that makes any impact. Oh, no impact. So no impact, no crater for the 4th one. All right, so now we're going to try these smaller marbles, a normal size marble. So I'm going to drop my normal size marble. This is marble or meteor number 5. Ooh, no impact. So no impact, no crater. Okay, here goes. I got another small one. Ooh, that was close. Almost made it through. Still no impact. For number 6, no impact, no crater. So you have no's all the way down right now. Okay. I'm going to drop another one, another small one. We're going to see this is our last one. We're going to see if it can make it through. And that's a no. So on your chart for this one, you're going to have no impacts and no craters all the way down. So interesting observation. Okay, so this is the first model. Now we're going to move down to your second chart. I'm going to swap out the models here. So I'm going to move this one out of the way, and I'm going to move our second model. Okay, so our second model here, you see I've got a pan, and remember the flower represents land, okay? So you'll notice this one has land, no water, and it doesn't have the tape across it, okay? So again, we're gonna drop 7 meteors and asteroids. So I'm gonna put all of the same size ones that we had, right? So we're gonna start off, I'm gonna start just like I did last time. We're gonna do with the biggest to the smallest, okay? So I'm gonna drop my biggest one. We're gonna see if we can get an impact. Ooh, definitely got an impact. So on your chart, you're gonna write for meteor 1, yes. And did it hit land? You're gonna write land. And where did it make a crater? When I pull it out, definitely made a crater. Okay, gonna drop another asteroid. Whoa, that made a big mess, got it all over me. So this one, number 2, did it make an impact? Yes. Did it hit on land or water? It hit on land. And did it leave a crater? Yes. And now I have the large marble. Ooh, dropped that one in. I'm just gonna leave that one in there. Did it impact? Yes. Did it hit on land or water? Land. And did it make a crater? Yes. So I'm gonna stop. I'm just gonna drop them now, and I want you to fill it in. So here's number 4. And here is number 5. We're gonna do a small one. So make sure you're filling in your chart. Here is number 6 is a small. So definitely hit there. And number 7, let's see if we can get a hit. So there you go. All right, go ahead and make sure you fill in your chart. How many of our meteors made an impact? Where did they impact, land or water? And did it leave a crater? Okay. So go ahead and fill that in, and we will talk about what that all means. All right, so we have finished collecting our data. Hopefully your notebook looks a lot different than mine, because mine on the screen right now is blank. But I want to talk about some reasons why we saw some differences between our 2 models. So before we start deciding what is what, hopefully you noticed that one model had the tape on top, the other model did not. So when we think about what that tape represents something in our on Earth that we would refer to as the atmosphere. So the atmosphere on Earth looks a little bit like this. So if you look at this picture, you can see that blue haze, and what the atmosphere is it's just a bunch of gas that surrounds planet Earth. It's where our weather happens, it's where the planes fly, but the atmosphere is a bunch of gas that surrounds planet Earth. That's important because, as you saw in the experiment, the tape did not allow a lot of the meteors and the asteroids to pass through. The atmosphere will actually kind of act as a shield for us. It's kind of nice because a lot of rocks enter our atmosphere and they burn up through friction with that gas. That gas is so thick, it goes from outer space where there's nothing to hitting a lot of gas that is surrounding Earth, and so it causes some friction and it burns up in the atmosphere. The one difference, though, between the model that you saw and how our atmosphere works is the bigger something is when it hits our atmosphere, the more likely that it will make it through. And the reason is because if it's really big, it's going to start burning, but it's the atmosphere has to burn a lot more of it away to prevent it from hitting. So something small is going to burn up really quick, and we see those as streaks in the sky. We call those shooting stars, but they're not really shooting stars. They're just meteors burning up in the atmosphere. But a big asteroid is going to come in. A lot of it's going to burn down, but if it's big enough, it will actually make it to Earth and actually have an impact. But if you look at pictures of the moon, you'll notice the moon looks a lot different. The moon here has a lot of craters, and this is a picture taken from one of our Apollo missions. This astronaut is actually inside of a crater. So this is a pretty big crater. If you looked at pictures of the moon actually has a lot of craters on it. And the reason is there's no atmosphere. You can even see when you're looking up into the sky, it's just black. You see the black of space. And that has a lot to do with the fact that there's no atmosphere. The reason we see blue sky on Earth is because the light entering our atmosphere gets scattered in the atmosphere, and the light that's scattered is the blue part of light. And we talked about that earlier this year, about how white light has all the colors of the rainbow. Well, when white light hits our atmosphere, blue light gets scattered, and that's why we see blue. Well, there's no atmosphere on the moon, so you just see the dark space, right? Dark black space. Because there's no atmosphere, though, everything, even a small little grain of sand, is going to hit the moon, and it's going to leave a little bit of a crater. There's going to be all kinds of debris and rocks and things like that on the moon. So everything's going to hit it, not going to burn up at all. So a little bit different. If you notice that in the model, every marble we dropped hit the pan that represented the moon. So I want to take you back to Earth, because Earth is mostly covered in water. So when we dropped our meteors, some of them that did make it through didn't actually hit land. They actually landed in water, and that's because most of Earth is water. So when we do get some of these meteors that do make it to the surface, they will splash down in the ocean and actually not even leave a crater. They'll just hit the water, and then they'll sink to the bottom of the ocean. And so we don't end up with a crater. The moon doesn't have any water, so the moon is going to just have craters everywhere. So that's one difference, is you're going to see a lot more craters, no atmosphere on the moon, whereas Earth does have an atmosphere, and it has a lot of water, which keeps it from having so many craters. I do want to show you a video here. This next video is of a news story about a meteor that did enter our atmosphere not too many years ago in Russia. It actually did make it to the Earth, and it caused a lot of problems, a lot of destruction, and it made the news. So I'm going to let you watch this, and then we'll come back and talk about it.
You're watching America This Morning America's #1 early morning news.
And we have more now on that breaking story this morning. The meteorite bursting through the atmosphere over Russia, injuring hundreds of folks on the ground.
It happened overnight in frigid Siberia, sending shocked residents into a state of panic. ABC's Kurit Radia filed this report just moments ago.
The meteorite was captured on car dashboard cameras and phones. A blinding flash of light streaking across the sky. And then, on the ground, chaos as fragments slammed into Earth. Witnesses say they thought a war had broken out. The blast shattered windows and knocked down a wall at this zinc factory. Officials say over 250 people were injured, mostly from broken glass. It's extremely cold in this part of Russia, below zero today, and schools closed after the windows were blown out. About 20,000 troops have been sent to the scene, as well as 3 aircraft which are surveying the damage from the sky. Scientists say the meteor shower was not related to an asteroid that will fly dangerously close to Earth today, but one estimate suggested this meteor was big, perhaps tens of tons. Kurit Radia, ABC News, Moscow.
Unbelievable video there. Now let's repeat what Kurit just said. That meteor shower is not believed to be related to that massive asteroid passing by Earth later today. Scientists say it will come within 17,000 miles of our planet, just around 2:25 p.m. Eastern Time. That is closer than weather and communication satellites, believe it or not, so some cell phone service could be disrupted temporarily.
All right, so pretty incredible, kind of scary video there. But I wanted to show you, so after that meteor hit Earth, or came through Russia, made all that trouble, they started looking around and noticed in one of the nearby lakes, there was this giant hole. And they're like, I bet that's where the meteor landed. And you can see how big that hole is in the ice, because you see the little men standing next to it. You can see how big it is. So they actually went down to the bottom of that lake and they found the meteor and they pulled it up. And what's really cool is how big that meteor is that entered our atmosphere. So that's how big it was when it hit the lake there. Didn't leave a crater because it hit where there was water, so no crater. So as it was coming through the atmosphere, it was burning up pieces of it. And so that's much smaller than it was, as it entered our atmosphere. So a lot of it burned up in the atmosphere from the friction, and still a pretty massive piece that managed to make contact with the Earth there. What's kind of cool to look at is that is a rock that is literally from out of this world. So another part of the universe, and we have a rock there. So scientists love it when they get a chance to kind of study these things, because it tells us a lot about how our universe formed and things like that, what kind of materials were available when planets were forming and things like that. So you can learn a lot from looking at meteorites. I also wanted to show you where a meteorite hit here in the United States. This is a crater in Arizona, and you can actually visit this, but it's a massive crater. This crater was actually created by a 150-foot wide meteor. So 150 foot, that is half the size of a football field. So think of a football field, half the size of that, and that's what hit right there. So imagine how much bigger it was before it hit Arizona or hit the Earth. But when it made contact, 150-foot wide piece. This is just a fragment of it, because when it collided with the Earth, it broke into a lot of pieces, and this was one of the biggest pieces that they found. What's funny is, for the longest time, people thought this was just a canyon, because the impact was from many, many years ago. So when you're on the ground, it just looks like a canyon. When you get up in the air and look down on it, you're like, looks like a crater. And you can actually visit this. It is a park, and you can see they got a little parking lot there with a visitor center where you can see this, the fragment. And then you can actually hike down into the crater, which would be kind of cool. And see how big and massive that is. All right, so hopefully through that you're able to see what the similarities, what the differences are between the Earth and the moon. Again, we talked about the sun. The sun, I feel like there's a lot of things that you can tell that are different from the sun. Not as many similarities, but we do have some similarities with the sun. And so hopefully you'll work through that this week. One of the things I like doing is listing those characteristics, similarities, differences. There's a really fun Venn diagram that I'm sure you're going to see this week as well, where we use 3 circles, which is kind of unique. Usually we only use 2. So make sure you find all those similarities, all those differences that we experienced today in the lab. And I hope you make some good discoveries this week. And as always, stay curious. I'll see you later.